Hi to everybody. I am Dr. M Jayaprakashvel, Associate Professor in the Department of Marine Biotechnology in Amet University. In this session, I'd like to discuss about the operation and maintenance of bioreactor. It is one of the important topics in the bioprocess technology as well as fermentation technology. Let me share the screen with you so that I can continue the presentation. Operation and maintenance of bioreactor is mainly required for the aseptic handling of the fermenters. Aseptic handling is the main important aspect of bioreactor maintenance as well as operation. There are three main considerations required for the operation as well as maintenance of bioreactor. Number one is sterility. You have to maintain the utmost sterile condition in the operation as well as maintenance of the bioreactor. Second thing is you have to take care of the mixing as well as aeration in a proper manner and in an optimized speed. And you have to also monitor and control the process. The process has to be always monitored to maintain the uniformity as well as to control the process if the conditions goes adversely or lower or higher. The sterility of the bioreactor mainly ensured through the construction and surface treatment quality. So we have to see some of the features which are involved in the sterility of the bioreactor. They are sealing of sensor and inlets. So these sensor as well as inlet are the main entry points for the microorganisms to enter into the bioreactor. So we have to have a proper sealing of sensors as well as inlets. And then during the reactor design, uniform surface has to be maintained. No acute angles should be there in the fermenter. The design of the fermenter should be in such a way that it should have uniform, smooth surface. So uniform as well as smooth surfaces avoid microbial attachment and thereby prevent the biofilm formation and ultimately reaches the very good sterility level. And we have to predetermine the sampling points. So where you are going to keep the sampling points as well as at what duration, at what interval you are collecting the samples that are to be predetermined. That will help us to maintain the sterility. And also we have to filter the air which is going through inlet and coming out through the outlet. So the air going in as well as the air coming out should be filtered in an efficient manner to maintain sterility. And we have to maintain the overpressure as well as temperature. This will adversely affect the microbial growth. Both it can enhance the contamination or it may reduce the microbial growth of the desired organism. And we have to use the quality raw materials as well as sterile raw material. The raw materials to be used must be quality as well as sterile. So most of the fermentation processes uses agricultural wastes or other cheap raw materials which are of low in quality and may have many of the microorganisms, contaminating microorganisms. That has to be properly treated, properly sterilized, and then to be taken to the process. And more important factor to maintain the sterility is to use the purest inoculant. Single culture, if you use, there won't be any contamination. So these are the factors to maintain the sterility. When we come to the mixing as well as aeration, dissolved oxygen content has to be maintained. Dissolved oxygen content is the one, the desired factor. It's the desired factor what we are working in the fermentation technology. So the dissolved oxygen, if it is uniform as well as if it is maximum, if it is optimum, then the process outcome will be very good. So when you are using the agitator as well as aerators, you may be having the problem of foam generation. So you have to have control measures for maintaining the foam. So there are anti-foam agents as well as baffles can be used to prevent the foam generation. And the foam generation, if you don't control, the heat and mass transfer may get affected. So all these factors implies that mixing and aeration are most important factors for maintaining the operation and for the maintenance of operation as well as proper processing in the fermentation fermenter. So when come to the process monitoring as well as control, The monitoring as well as control mechanisms are the integral part of high quality bioreactor. So the process controller is the major component in a bioreactor. It is we can say that it is the heart of the bioreactor. The process controller can be designed for precision as well as sophistication. The major factors controlled by the process controller are temperature. For increasing the temperature, heater will be there inside, and for reducing the temperature, cooling pipes will be fitted outside. So there will be temperature probes will be there that will be detecting the temperature increase or decrease. Based on that, if the temperature is getting decreased, the heater will be switched on, and if the temperature is going higher, cooling pipes will be switched on. So in such a way, this temperature probes will be working, and the process controller will control the temperature probe as well as heater and cooling pipes. So when you come to the next category, that is most important category is pH. For pH, maintaining pH, you may have to use the sterilized electrodes. So the lower pH minimum and as well as higher pH maximum values are to be recorded at every regular intervals, and so that the pH can be monitored as well as pH can be maintained. So if the pH is getting lower, the pH probe will be detecting the lower pH, means you have to add the alkali automatically through the process controller. And if the pH is getting higher, it increases, means we have to add acid through uh, the certain ports. So the process controller may also have to control the foam. So foam can be controlled by mechanical metering, which is an additional equipment to be fitted with the process controller and bioreactor. And some people are using anti-foam agents as well as such as sand and silica. The another important parameter that the process controller are monitoring is partial pressure of dissolved oxygen, which is known as PO2. So the agitated speed, air inlet, substrate utilization, as well as metabolism are greatly affected by the partial pressure of the dissolved oxygen. So it has to be properly monitored and properly regulated through the oxygen probes controlled by the process controller. So I would like to conclude that the operation and maintenance of bioreactor has three main considerations. Number one is sterility. Number two is mixing and aeration. Number three is monitoring and control of processes. Thank you.